All right, so the next thing we're going to talk about today, first off, thank you, Dr. Stark. And now we're excited to transition to a lot of the pelleting work we've done over the past year. And remember, our grad students have really took the lead in getting this accomplished, and so we appreciate all their hard work. And so now we're going to focus on what are some key concepts in terms of diet formulation and nutrient composition, and how those are going to influence pellet quality. So remember, when we determine pellet quality, we're conducting research or a QA program at a mill. What we're going to measure is pellet durability index. But for you as the producer, what really matters is the percentage of fines at the feeder. So although we're reporting pellet durability index as a measure of pellet quality, it's ultimately up to you to determine, okay, how does this influence things in your system? What do the percentage fines look like in the feeder? How does this influence my pigs? So taking this information and really transition it and applying it to your system is going to bring you the most value. And so we think back to a lot of the work Dr. Binke initially did and followed up by Dr. Fahrenholtz at the different factors that influence pellet quality. We know that dye thickness can influence pellet quality, your conditioning temperature, the particle size has a small influence, and also your production rate. The thing as a nutritionist that we need to think about, we also can influence that final pellet quality. And that diet formulation plays a large role in pellet quality, and what our pellets look like or the percentage fines. And so we know some key factors like added fat in the diet and how that influences things. But what we really want to dive into are what are some recent trends and changes in diet formulations, and what are some things going on in the background that could influence this pellet quality, or things we need to think about. So the main composition characteristics we want to discuss today are nutrient compositions. Or first is fat. You know that as we add fat to the diet, it acts as a lubricant, therefore it pushes that feed through the dye, which is very beneficial in terms of production rate. However, the faster you move that through the dye, you have less compaction and you're reducing your pellet quality. Everybody knows this. That's why we have PPLA systems, or post-pellet liquid applications, where we add fat on after the dye and we only put a certain percentage in the mixer. But what we're going to discuss today is how are some recent changes in diet formulation influencing that, just more of as a reminder, things to keep in the back of your mind as you're formulating these diets. Then we're going to get into the discussion of how do carbohydrates and proteins influence pellet quality. We have chemical compositions, things are changing as the steams apply. We have heat and moisture, proteins are unfolding, starches are acting differently. And so how does this all tie together to influence pellet quality? The main thing we're going to focus on today is starch, and then we'll touch a little bit on protein. So I know fiber is a whole nother thing, but we won't include that in today's discussion. So as we all know, as we increase the percent of fat in the diet, we're going to reduce that pellet quality. So you can see this is just some diets we pelleted here at K-State. PDI being our pellet durability index. As you increase the fat in the diet from 1.5 to just over 3%, your PDI drops from a good pellet of 90% down to that of 75%. So as we increase fat in the diet, you're getting more lubrication, that feed's moving through the dye. You're getting less of that compaction and binding, therefore reducing your pellet quality. I think everybody's aware of this. This isn't new news to anyone. But what I want to focus on is how recent trends in diet formulation, if you make changes in your least cost formulator, how that fat might be moving or decreasing within the diet or increasing, and how that can influence pellet quality. And so this was a study that we conducted, and this actually is a set of poultry diets. So bear with me, we're going to talk about some poultry diet formulation, the subsequent effects on pellet quality, and then we'll tie it back to the pig side. But you can see when you're doing your least cost diet formulation, if you set your minimum energy value, but then increase the amount of crystalline amino acids you use, when we increase those crystalline amino acids, what that's doing is removing some of the soybean meal, which increases your corn, which increases your energy value. So if you're formulating to a set energy value, therefore you're going to have less fat in the diet. So you can see this is just an example of diets here. As we increase our crystalline amino acids, adding valine to the diet or valine and isoleucine to the diet, it reduces our amount of soybean meal, increases our amount of corn, and because we're formulating to this set energy value, we're able to decrease the amount of fat by roughly 0.6, 0.7%. So if we were pelleting these diets, all things held consistent, just our diets changed, what does that do to pellet quality? So even though it's just, minor changes in the fat, less than 1%, we still see a bump in pellet quality as we remove that fat out of the diet because of our formulation strategy being including crystalline amino acids in the diet. So we have 3 different ways we measure pellet quality here at K-State, or pellet durability index. That's the standard tumble box method, which is you just put the pellets in the box and turn it, and they just turn for a set amount of time, and then you sift off the fines and measure the percent of pellets left, or the PDI. We have the modified method, which is the exact same thing, except we put hex nuts in that tumble box that makes it more abrasive and is harder on the pellets. And then we have the Holman method, which you essentially put your pellets in a machine. It goes through a vortex where air knocks the pellets around, breaks them up, and then we sift those fines off and measure pellet quality. So in terms of our diet formulation, you can see as we increase our crystalline amino acids, really what we're doing here is removing fat from the diet by up to 0.7%. We get an improvement in our PDI. So once again, this shouldn't be surprising to anybody, but it's something to keep in mind as we're changing these diet formulations. So with our standard, we get roughly a 10% improvement, our modified, roughly a 15% improvement, and for the Holman, roughly 20%. Okay, the other thing I want to touch base on is the difference in these methodologies. Okay, so remember, what you're trying to do is predict the amount of fines at the feeder, so that your system is going to be different from other systems, and that should help guide you in what method you should do to estimate pellet quality. Notice the standard PDI method here is going to have higher PDIs than the modified, and actually the Holman's kind of in between. Okay, nice thing about a Holman, it doesn't take as much sample. It's also only takes 60 seconds, so it's a quick method. But you do have 3 different options here, and depending on how you measure pellet durability index, your average values will be different because of how those methodologies work, how abrasive they are on the pellets. So just by happen chance, we received funding for the National Pork Board to look at formulating different diets and understanding how these diets, when pelleted, influence amino acid digestibility. So we're going to talk about that in the second half of this presentation, but it really plays nicely into this fat and pellet quality. So notice we had 2 different diets. These are just basic corn soy diets, no byproducts or co-products in them. And as we increase our crystalline amino acids, we decrease the amount of fat from 1.55% to 0.85%. This results in a 10% increase in your PDI. So this is a phase 3 swine diet. And so just remember, as you're adding more crystalline amino acids, reducing that soybean meal, increasing that corn, when you're balancing these diets for energy or formulating to a set energy value, that will allow you to remove some of that fat, which actually has a positive effect on pellet quality. Same thing if we have a high byproduct diet. Notice these diets have 20% distillers, 15% bakery meal. Same thing, when you're balancing for energy value, that allows you to remove some of that fat in the diet and results in an increase in pellet durability index. So now moving on, I want to focus on starch and proteins. So how are starch and proteins interacting to influence pellet quality? And so when we're pelleting, first we had the conditioning. And in the conditioning process, this is when you're adding steam to the conditioner. So you're getting this heat and moisture. So remember, if we're pelleting at about 185, we're probably going to add 4% moisture to that conditioner. Our final temperature is going to be roughly 185 before we push it through the die. Okay. And so what happens as you add that heat and moisture, you get your materials that go from this glassy state to a rubbery state. Okay. And so what that means is you go from this glassy state, you start to get water uptake, your starch granules start to swell, and your proteins start to melt. So this rubbery state's where we really start to have this binding of materials. So you have the binding taking place by either your covalent bonds, your ionic bonds, or your hydrogen bonds. And this is going to be between your starch and your proteins. And so the moisture, depending on the chemical composition of your diets, when that transition happens from the glassy to the rubbery state, is going to depend on what your diet's made up of and the moisture and the temperature at which that starts to transition. So once we go, this is really what we're trying to achieve here to get our pellets to bind together and improve our pellet quality. And so you have the proteins binding the starch granules together. And during this rubbery state, also remember, you have proteins unfolding, you have starches swelling and changes in the amylose, amylopectin, all those kind of things. So this got to thinking about, okay, well, maybe if we have starch that starts to get to the rubbery state sooner, how could we do that, and could that potentially improve pellet quality? So one of the first things we tested was, what about fine particles of corn? There has a greater surface area to volume ratio. They're going to get exposure to that moisture, to that heat. Can we potentially use that to improve pellet quality? And so what we did is we replaced corn with a percentage of what we called fine corn particles. And these are particles just under 200 microns. And so we added 10, 20% of these fine corn particles and pelleted the diets at 175 and 185 degrees Fahrenheit to see how that influenced pellet quality. We thought maybe, if we hit that TG or that glass transition into the rubbery states at a lower temperature, there could be some opportunity there. And that's why we chose these two different temperatures. But you notice as we increase the percentage of fine corn particles in the diet, we did not see an increase in pellet quality. However, as we discussed, there's other things that influence pellet quality. So as we increase conditioning temperature from 175 to 185, we did see that bump in pellet quality from roughly 75 to 85%. So a 10% increase. The next thought was, well, fine particles didn't work. Why don't we just add straight cornstarch? So we added cornstarch to the diet at 5 and 10%. We actually chose to do two different die thicknesses in this study, so a 1/2 inch thick die and a 0.87 inch thick die. But as we noticed, as we increased the amount of starch in the diet, we actually decreased pellet quality. So you can see in the thin die, we went from a PDI, these are modified PDIs, pretty low PDIs, of 50 to 30%, in the thicker die, 76 down to 62%. So adding that cornstarch did not influence or improve our pellet quality. Once again, though, do note, as we know, a thicker die, there's more opportunity as that feed has to pass through the die for a longer period of time. We have more opportunity for compaction and binding, and we see that increase in pellet quality from the roughly 40% up to 70%. Okay, so now we're starting to think maybe starch isn't really driving these bonds and this improvement in pellet quality. And, we thought it was this transition in state. As the starch cooks, gelatinizes, it's going to assist in bonding. And so we really started to look into that. First off, sorry, I want to take a step. Caitlin Evans ran these two studies and was a part of them, and we really appreciate her effort. She will be wrapping up here in December, has a job with the FDA, and she's really been a huge asset to our program. So thanks, Caitlin, for all you've done there. Next on, Courtney Trulock, who just defended her thesis. Dr. Trulock's now down in Texas, working with High Pro Feeds and their feed mill. But Courtney had the opportunity to look at different corn types. So she had a conventional corn or control corn, and then EFC. So EFC is the Inogen feed corn. And what this corn is it's a corn variety that has a high expression for amylase. And so that amylase, when it interacts with the moisture and the high temperature, we actually saw an increase in starch gelatinization when all other processing parameters were kept consistent. So you can see in our final pellets, we had increased our starch gelatinization from 11.7 to 13.4%. We also measured this across 2 different dye types and 3 conditioning temperatures. So I will point out, we determined if that there were no interactions. So corn type did not depend on dye type or conditioning temperature. So all we're going to do here is look at main effects. So although it wasn't statistical, we did see a numerical increase in gelatinized starch as we increased the dye. So roughly a 1% increase. And then as we increased our conditioning temperature, we saw an increase in starch gelatinization from 12 to 13.4%. So it's important to note, one, we are seeing an increase in gelatinization, but still our gelatinization in the pelleting process in our final pellets is only 12 to 13%. You know, if you're extruding dog food, you get a lot more gelatinization in that extrusion process than we see in the pelleting process, but there is still some gelatinization. So what we would kind of expect is, you know, if this cooking this starch, getting it to gelatinize, it should potentially help with bonding of particles, improve pellet quality based on some of our thought processes. But what we saw when we kept all processing conditions the same at different dyes, different conditioning temperatures, remember we had 2 different corn types. With those 2 different corn types, we were able to see a difference in starch gelatinization. But that did not translate into an improvement in pellet quality, okay? We did see an increase in gelatinization or a numerical increase in gelatinization with the dye-LD ratio or the thicker dye. However, we did see a nice improvement in pellet quality, 82 to 90%. And as we increase that conditioning temperature, we see an increase in our pellet quality. Okay, so there are parameters, processing things we can do to improve our pellet quality. But this data is really leading me to believe that it's not really that starch gelatinization that is influencing that pellet quality in this process. And so when we look at starch gelatinization compared to PDI or pellet durability index, we do see that they are there's a positive correlation. Now the R-squared value is only a 0.42, but there is that positive correlation. But I want you to challenge you to remember, correlation does not always mean causation, okay? So we can potentially use starch gelatinization as some kind of measure of percent cook or potential correlation with PDI, but I don't believe that that's exactly what's causing those influence in PDI. And so what this has kind of led us to hypothesize is what's having a greater effect on the pellet quality is potentially these melted proteins and how this protein matrix interacts with those starch granules, okay? So the starch is important. It allows that moisture to be absorbed, which helps with unfolding in different things, but these proteins seem to have a lot of influence on that pellet quality and the pellet quality of the diet. So this kind of leads us into some things we're excited to look into in the future. We've done some preliminary data at this step. We haven't done a lot of research, hopefully get to do that in 2020, the rest of 2020 or 2021. But one thing Caitlin Evans did have the opportunity to do was she did some research looking at what we call naive versus processed proteins. So thinking about if you have a protein, the protein of soybeans, and so we include whole soybeans in the diet, versus soybean meal. So that soybean meal has already been through a processing step. Those proteins have been exposed to heat. We start to see some changes. Does that influence the binding properties? And we see as we increase this percentage of soybeans in the diet, we actually saw an improvement in our pellet quality or our PDI. So really the take-home message here is that the type of protein, what the condition of that protein is, if it's been processed, could influence pellet quality of our diets. And so there's a lot of opportunity here of things for us to consider when trying to influence pellet quality moving forward. So now we're going to transition into how does pelleting influence amino acid digestibility? Okay. Is there anything we need to be concerned with? Are there benefits? What is the overall effect there? And we really appreciate the support we got from the National Pork Board. This has been a part of Kara Dunmire's dissertation. She's really taken the lead on this work. And we've seen some really neat things. So Kara and I, we got to discussing with the group and started thinking about, you know, we talked about how increasing conditioning temperature improves pellet quality. We also know that if we condition feed to a certain temperature, there's potential benefits in terms of feed safety. So that's pushing the industry to condition to higher temperatures. Well, could we potentially get to the point where we have a negative impact on the amino acid digestibility in the feed? And the other side of this, as we increase ingredients or different ingredients we use, we're kind of exposing some opportunities for a negative effect. So one, by adding ingredients such as bakery meal or distiller's grains or others that might have increased amounts of reducing sugars, and then also free amino acids, could we be potentially initiating the Maillard or browning reaction? And so remember, the browning reaction is when we have these reducing sugars, or in this example, glucose, binds to that free amine group on your amino acids. And this protein with this glucose forms your amidori compound, and that makes that lysine no longer digestible or available to the pig to utilize, okay? And so remember, lysine is going to have the greatest opportunity of binding because of this free amine group that lysine has. Lysine is also very important to us. So what we wanted to determine, okay, at these higher pelleting temperatures, depending on the diet type, could we potentially bind these amino acids? The other thing I want to point out is, as a product of this amidori compound, we have these melanoidins, okay? These melanoidins, something we tried to utilize in this experiment to potentially measure the browning reaction, or could it be a quality measure? So we'll touch on that some as well. So in order to test this hypothesis or achieve this objective, we designed the experiment as a 2x2 factorial. So we had 2 crystalline amino acid levels. So we had a diet with just a minimal amount of crystalline amino acids, being lysine, methionine, threonine, or high amounts of crystalline amino acids, so including all the way up to isoleucine and valine. Then we had 2 different diet types to try to make them practical, but increase that amount of reducing sugars. So we added bakery meal and distiller's grains to the diets. And then we either fed those diets in mash form or pellet form. So that you can just see our diets here. Our high reducing sugar diets, we achieved that objective by adding DDGs and bakery meal to the diet. And then we either had a typical crystalline amino acid diet or high inclusion of crystalline amino acids to include isoleucine and valine. So the first thing I want to talk about is these melanoidins. That one's hard for me to say. So we measure the absorbance value on the ingredients received. So the ingredients we used in this project were corn, soybean meal, DDGs, and bakery. And we did this, first we did amino acid digestibility study that we'll talk about. And then second, we actually did a growth performance study in phase 3 nursery pigs. due to circumstance, we actually had to process the nursery pig diets at North Carolina State University. So for our digestibility study, those ingredients were sourced in the Midwest. For our growth performance study, those ingredients were sourced on the East Coast. But you can still see we have an increase in this melanoidin absorbance values on all of our ingredients that have been processed, being your soybean meal, distiller's grain, and bakery meal, compared to that of corn. So we can see that indication that there is a difference in ingredients that have gone through previous processing than just ground corn. So we have our 4 different diet types, and we pelleted these diets and either fed them in mash form or pellet form. And so this is just indicates what I want to get across here is the pelleting temperatures we did achieve. So we had to essentially, our conditioning temperatures here, you can see our high crystalline amino acid and reducing sugar diets were pelleted at roughly 175 to 185 a conditioning temperature, and then our hot pellet temperature at 185 to 193. So really our goal was we pelleted these on our 5-ton here at K-State. We tried to get it to the hottest temperature we could without plugging that die, which did become a challenge, but we were able to accomplish the pelleting. So when we look at how the diet type as well as the pelleting process influence this product of the browning reaction or your melanoidin, and so we can see here that our diets that have our high concentrations of reducing sugars or those byproducts, the distiller's grains in the bakery meal, as well as the soybean meal, we have an increased absorbance value compared to our control diets. And this is consistent in both the mash and pelleted diets. Okay. When we look at the control diets that were pelleted versus those fed in the mash form, there's really no increase in that absorbance value. And then we potentially, in this diet that we think has the most opportunity for the browning reaction during the pelleting process, because it has high free amino acids as well as reducing sugars, there may be a slight bump in your absorbance values, but really, it's hard to conclude on these values. So really the take-home message here, there is potential opportunity to use this as a to determine a degree of process, but something we really need to further our research on to try to determine how it's correlated with digestibility or growth performance. So we designed this experiment as a factorial, so that way if we're potentially reducing the digestibility of amino acids, depending on diet type, whether it's increasing the amount of crystalline amino acids or the amount of reducing sugars, we would detect the interaction that would let us know, hey, if we have a high reducing sugar, high crystalline amino acid diet, we may run into issues. However, if we have a typical corn soy diet, we may not have any issues. The other thing is we were able to just measure main effects of if we pellet at these temperatures, are we potentially improving or reducing digestibility, how do diet types compare, and et cetera. So we did not detect any interactions. So what that told us was the main effect of pelleting either improved or in this case did improve digestibility. It did not depend on diet type. So if I'm pelleting at the conditions reported within this study, no matter if I have a high reducing sugar, high crystalline amino acid diet, or a typical corn soy diet, I shouldn't have any difference in the response in amino acid digestibility in that pelleted diet. Okay, so what we determined when we pelleted diets, we saw an increase in SID lysine or the percentage digestibility. So we got about a 2% increase in lysine digestibility when those diets were pelleted. There was no difference in the crystalline amino acid diets. However, there was a numerical increase in lysine digestibility with a high level of crystalline amino acids. And our diets that contained distiller's grains and bakery meal actually had a reduction in lysine digestibility. And these responses were pretty consistent throughout all of the amino acids. We're going to touch on the main ones here. So next, for methionine, you can see in the pelleted diets, we had an increase in methionine digestibility, and then no difference in the crystalline amino acid diets. But as we increase the amount of byproducts, distillers, and bakery meal in the diet, we did see a decrease in methionine digestibility. For threonine digestibility increased in the pelleted diets versus pigs fed the mash diets. There was no difference in the crystalline amino acid diets, and we had a reduction in threonine digestibility in the reducing sugar diets. So I really want to take a second before we finish up to thank Dr. Stein and his group at Illinois for helping us with this study. Kara Dunmeyer had the opportunity to go to the University of Illinois. We pelleted the diets here at K-State, sent them to the University of Illinois, where we conducted these ileal digestibility studies on growing pigs. Lastly, we're going to talk about the digestibility of tryptophan. In our pelleted diets, we did see an increase in tryptophan digestibility. There was also an increase in tryptophan digestibility in the crystalline amino acid diets, as well as the diets, as well as a decrease in tryptophan digestibility in the diets containing distillers grains and bakery meal. So just to confirm our response, we also wanted to determine the effects on growth performance. So when we formulated the diets for growth performance, we did use book values for digestibility for all of our ingredients. And remember, we pelleted these diets at NC State. And so we appreciate Dr. Fahrenholtz and his groups for helping us getting these diets pelleted. Then we shipped them back here to K-State, where we ran this study in our nursery. And we appreciate the swine group's help with that as well. And so you can see these diets we were able to pellet at a little bit higher temperature, with our hot pellets achieving 193 to 198 degrees Fahrenheit. Just coming back to those melanoidins, once again, once we added those byproducts to the diet, you see an increase in that evidence of a browning reaction because of adding those ingredients that have been processed. However, there's really no difference between the pelleted and the mash diets in this example. So based on this measurement of the browning reaction, we're not picking up any difference when we're pelleting these diets. The conditions weren't extreme enough to increase that melanoidin absorbance value. So once again, there were no interactions demonstrating that the diets did not depend on each other in potentially improving or reducing their performance. And so from a main effect standpoint on feed efficiency, our pelleted diets, we did have a roughly an 8% improvement in feed to gain in pelleted diets versus pigs fed the mash diets. There was no difference in the crystalline amino acid diets, and we actually saw improvement in feed efficiency in the diets containing distillers grains and bakery meal. So lastly, I want to thank all of our sponsors that have gone in to support our program and fund research that has been either was presented here today or published in our Swine Day that has now been released. Once again, really want to thank all the grad students for their hard work. They continue to push our program forward, and we're looking forward to bringing on new grad students to help continue push our program. And with that, we would be happy to answer any questions.